Alright, so let's continue with this. Let's see. By the way, my dog is like under the chair, so if I move, anyways. Alright, so we have the equation 27 equals to negative 25x plus 18x minus 8. So let's see now. Let's write down our action plan. This time, I'm not gonna write what's going on. I'm gonna write the rules. Remember, that's basically your depth of knowledge explanation. So for example, what is the first thing that we need to look at when we solve linear equations? Do we have distributive property? And I don't see any number, any parentheses being trying to be multiplied, so no. All right, so then do I have fractions? So fractions. Now you have to write distributive property. I don't have to write distributive property. I just write DP. Fractions. No. Okay. The next thing is what? Do I have like terms on the same side of the equation? Well, this is one side and this is the other side. So here I notice that I have negative 25x and I have positive 18. So therefore I do have like terms. Wow, finally. So now you tell me, what is negative 25 plus 18? Negative 25 plus 18 is negative 7. So that means that this, when I combine them, I get negative 7x. Okay, so I write down 27 equals to negative 7x minus 8. So far so good? Okay then. So like terms, I did have like terms. You have to write like terms. And what were the like terms? The like terms were negative 25x and 18x. Okay, those were the like terms. So we're Gucci with that. All right, what else? What's the next thing I have to look for? Variables on both sides. Do I have variables on both sides? Nope. So therefore, I write no. Then the next thing is the additive inverse. Do I have additive inverse? Is there a number that is being increased or decreased by the variable? Yes, look. Negative 7x is being decreased by 8. So 8, I need to use the additive inverse of negative 8, which is positive 8. And remember, what you do to one side, you do to the other. I'm not gonna put plus 8 on the under the 7 because that's not where the other side is. The other side is over the equal sign. So all right, so this cancels out. I copy down the negative 7x, and now what is 27 plus 8? There you go, 35. And now I am going to use the multiplicative inverse of the number multiplying the variable. In this case, negative 7 is multiplying x, so negative 7. What is the multiplicative inverse of negative 7? Well, which is negative 1 over 7. Remember, this is negative 7 over 1. So then the multiplicative inverse or reciprocal should be negative 1 over 7. So I'm going to multiply the whole equation by that. And you know what's going to happen, right? So I'm going to multiply by negative 1 over 7. You could say 1 over negative 7, negative 1 over 7, or just negative and then 1 over 7. However you want it, it's still the same thing, however you do it. Okay, so we get that. Now what? Well, what's the idea behind multiplying by the reciprocal? To cancel out. Look, when you multiply by negative 7 and divide by negative 7, they cancel out. That leaves you with your x. Whoa, that leaves you with your x. No, that's not right. Okay, so now look, negative times positive is negative. So my answer here is going to be negative. Now 35 divided by 7 is 5. So my answer is x equals 5. X equals, negative 5, not 5. Okay, and that's it. That's basically what you do. All right, so on the next series of problems, if you're my student, you need to write down the steps and in full sentences. You want to write it down, a paragraph, a proof, then that's fine. But if you're not, then you could just solve the equation but still follow the golden rules. They will never fail you, okay? So then, let's solve the next one. And this time, I'm gonna start going a little faster. If you need to, you could pause it, you could rewind it, but I still need to go a little faster, okay? Oh, okay, so let's see now. All right, so let's see now. What you write in here is your action plan. So I start with, do I have distributive property? No. Do I have fractions? No. Do I have like terms on the same side of the equation? Yes, 5x and 7x. So I'm gonna combine them so they become 12x. And now I continue. You see, once you get the hang of it, you could skip the steps because you will already know what to do. All right, so then do I have variables on both sides? No. Do I have additive inverse? I don't see any number being increased or decreased by the variable. So then the next one is the multiplicative inverse. Yes, of 12. I know what you can say. Becker, why don't we just divide by 12 on both sides? Definitely we can divide by 12 on both sides, but once again, for the purposes being, I need you to use the multiplicative inverse the way it's supposed to be used. Okay, so now remember, the idea behind the multiplicative inverse is to cancel it out, and we already seen that 1 times 12x is 12x over, or if you want to put a 1 under here, it's fine. 1 times 12x is 12x, and 12 times 1 is 12. Okay, and then on the other side, 72 times 1 is 72 over 12. You see that? That's basically what you were telling me. Divide both sides by 12. But once again, the idea behind dividing by 12 on both sides is because you use your multiplicative inverse. I know it sounds corny. I know it's bothersome, but hey, what can I do? Anyways, I don't know what 72 divided by 12 is, so 6. Oh, okay. We got that, right? Cool then. All right, let's go here. So what do I have? I have this equation, and now I have to figure what to do. So once again, what is the first rule that you have to look for? Correct. Is there a distributive property? And you write it down right here, okay? You see, write down your action plan. Even if you are not my student, you could write it on a loose leaf or whatever. All right, so distributive property, yes, I see a number followed by parentheses. Therefore, I have to multiply. You see, there is no plus or minus here, so that means multiplication. This -2 has nothing to do with the distributive property. Okay. Then what was that? Fractions. I don't have fractions. Like terms. Well, I do have like terms right here. See that? They're just numbers. Variables on both sides? No. Okay. Additive inverse. Well, is there a plus or a minus between the letter and a number? In other words, is the x being increased by a number? Yeah, it's been increased by 6. Oh, okay, so use the additive inverse of 6. All right, and then we're gonna use the multiplicative inverse of 8, which is 1 over 8. Remember, this is 8 over 1, so multiplicative inverse is 1 over 8. Okay, cool then. So then what do we get? Well, -28. The idea behind the multiplicative inverse is to get rid of the number that was multiplying the variable. Multiplying by 8 and dividing by 8 is the same. They cancel out, so that leaves you with x. On the other side, you get -28 over 8. And now it's funny because now, wait, hold on, maybe this is wrong. No, it's not wrong. I mean, it's okay to get a fraction, which is a decimal, which is a rational number. So let's take half of 28. What's half of 28? That's 14, right? And half of 8 is 4, correct? And now half of 14 is 7. So -7, and half of 4 is 2. That's it. It cannot be reduced anymore, so that's what x is. Negative 7 over 2, 3.5. All right? Oh, hell no, that's too easy, too easy, too easy. Oh my God. So here, oh, let's see. No distributive property, no fractions, no like terms, no variables on both sides, no additive inverse. So therefore, just multiplicative inverse. But if you got the hang of the multiplicative inverse, then I'm gonna let you slide and we're just gonna do it the easy way, okay? So here, I'm just gonna divide by 2 on both sides instead of multiplying by 1 over 2. So 2 cancels out and x is 3, okay? All right, this is the moment you've been waiting for. There are 2 ways of solving this. Now look, hopefully I can do this, I can do this, I can do this, I can do this, I can do this. Give me a second, give me a second. Okay. Look, for example, do I have distributive property? No. Do I have fractions? Yes. Okay. So if I do have fractions, I'm gonna have to multiply by the common denominator. In this case, the common denominator is 3. You know what? Let's just do it right here. I wanna show you. Oh, okay, right. So I'm gonna multiply the whole thing by the common denominator. So I'm gonna multiply the whole thing by 3 because that's the only denominator. Okay, so let's see now. If I multiply by the common denominator, I'm multiplying by 3. So 3 times 2 is 6. Equals to 12. Now 6 divided by 3 is 2. And we still have the x, right? And now we divide both sides by 2. And this is 6. If you didn't follow, oh shoot, sorry. Okay, that's better. If you didn't follow right now, then just write down the rules and do it the way I've been teaching you. Once you get the hang of it, then you could start doing it this method. All right, so what happens is that I didn't have any distributive property, but I had fractions, so I multiplied by the common denominator. So I did, and it came out to be 2x equal 12. Then of course I went down through the other rules. Like terms, no. Variables on both sides, no. Additive inverse, no. Multiplicative inverse, yes I do, because I do have a number multiplying the x, but since we want to be lazy, I just divided by 2, because that's the idea behind the multiplicative inverse. Okay, it will cancel the number and it will basically provide us with the answer. All right then, the other way I wanted to do it is the following. So I'm gonna rewrite the equation. 2/3 x equal 4. Let's say I forget about fractions. Let's say I went to distributive property, then fractions, and I forgot, and I said like terms. Then I said variables on both sides, no. Additive inverse, no. Then guess what? If the equation is as simple as this one, and I got to the last step, which is the multiplicative inverse, then look what happens when I use the multiplicative inverse. Well, what is the multiplicative inverse? Well, of 2 over 3 must be 3 over 2. Okay, and now watch what happens. Multiplying by 3 and dividing by 3 cancel out. Multiplying by 2 and dividing by 2 cancel out. In other words, 3 times 2 is 6. 2 times 3 is 6. So 6 divided by 6 is 1. 1 what? 1x. And now 4 times 3 is 12. Divided by 2? 6. Same thing. So that's why I always urge you, like sometimes you forget about the fractions and you end up with a fraction on the variable that you want. Then guess what? The multiplicative inverse will bail you out. All right, so now you know something that I hadn't explained before. All right, so let's move on to the next one. Once again, look at this. Simple fraction, okay? I could use all the rules. I could say, okay, do I have distributive property? No. Do I have fractions? And I could say yes, but look at the format. It looks like the other equation. A fraction x equals a number. A fraction x equals a number. So I could just multiply, okay, 4 over 7x equals 4. I could just multiply by the reciprocal or multiplicative inverse. of this one. You see that? Boom, 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 boom. So now, please, I don't want to confuse you. If you start to get confused, then use the method with all the rules and follow them. Okay, tip to toe. All right. So 7 times 4 is 28. 4 times 7 is 28. They cancel out. Leaves you with x, right? Okay. Now, multiplying by 4 and dividing by 4, they cancel. That means they become 1. 1 times 7 is 7. Simple as that. Of course, now I give you the golden rules, blah, 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 blah. You already know. You know what? If you're not my students, I'll put them right here so you could read them. Okay, there you go. You got them. You could pause them, whatever. Let's go on to, and of course, then I provide you with an example on how to do it. See that? Okay. Cool then. So you see, distributive property, yes, and I give you the example right here. Then I solve it. At this point, you already know what's going on. I'm just showing you the example. And you see when I use the multiplicative inverse of 12, which is basically 1 over 12. So I multiply by 1 over 12, and I end up with my answer. Cool? Sure. Okay. So then, what do we mean by consecutive integers? All right. This is what happens. Consecutive integers are nothing more than numbers that go by ones. Like for example, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 right? Okay. Now, if you don't know the numbers, then you could use a variable. Like for example, if you don't know, okay, so if unknown, then the first number will be x or n or a variable. The second number is the gap between one number and the other. They go by ones, so the next number is going to be x plus 1, x plus 2, x plus 4, and so on and so forth. Okay then. Now, how about consecutive even numbers? Well, what are even numbers? Numbers that are divisible by 2, right? So, boom, 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 boom. But if you don't know, when just representation of the number, let's say the first number is always going to be x. The second one, well, what is the gap between the numbers? They go by 2s, right? So, then the next number is x plus 2. The next one is going to be x plus 4, x plus 6, and so on and so forth. Funny thing now is that we're talking about the consecutive odd integers, like 1, 3, 5, 7, 9, and so on and so forth. Well, if you don't know it, you could always represent it with a letter. And then, remember, this is the representation of the numbers, like the gap between numbers. This is not really an odd number. This is the representation. So the odd numbers go by 2s as well, right? So the next number is going to be by 2. So x plus 2, x plus 4, x plus 6, and so on and so forth. The reason I say that is because when you have, when you look at this, you're like, wait, hold on a second, but you represented the odd integers and the even integers the same. Well, yeah, because they go by 2s. They have the same gap. Got it? All right then. So that's it. Oh, by the way, the number before x, like the first one, it will be what? X minus 2. And this one will be x minus 4. If we're talking about the negative numbers, right? Minus 4, minus 2, plus 0, plus 2, plus 4, plus 6. If you have any questions, you can ask me. I don't have a problem with that. I'll answer. Alrighty, back to more equations. Hopefully by now you should be acquainted with this. So anyway, for the purposes being, I'm going to continue following the golden rules of solving linear equations. So, all right, if you're my student in here, you write like, what is the problem asking me to do? How will I answer the problem? What steps do I need to take in order to answer the problem? I will use the following rules to solve linear equations, and then you start labeling the steps, okay? And me, I'm just gonna solve it, still using the golden rules, but all right, so let's see now. Do I have distributive property here? Yes, so then negative 3 times 2 is negative 6, and negative 3 times x is negative 3x, which is minus 3x. The negative 5 is not part of this, so minus 5 equal 22. And then I am going to go on to the next rule, okay? So the first one was distributive property. The second one is fractions. The third one is like terms. Like terms, not like i's. The fourth one is variables on both sides. The fifth one is additive inverse. The sixth one is multiplicative inverse or reciprocal. So you see, I write them all down. It doesn't mean that I'm gonna use them all. So distributive property, check. Okay, so yes, there was. Fractions, no, so no. Like terms on the same side. Well, this is one of the sides. So are there like terms? Yes, I have negative 6 and I have negative 5. So that makes it negative 11, right? Minus 3x. And then equal 22. Now, variables on both sides? Nope, 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 nope. Then do I have additive inverse? Well, think about it. You have negative 3 times x. That is not additive inverse. Is x being decreased or increased by something? Sure. X is being decreased by 11. Remember, this is not the sign for this number. This is the sign for this number. If you want me to rewrite it in a different way, I'll do it. I'll put the negative 3x first and then the minus 11 later. Alright, so now you could see that x is being decreased by 11. So I'm going to use the additive inverse of 11. By now you must be tired. You must be saying, yeah, okay, I got the hang of this. I'm Gucci with this. And now I'm going to use the multiplicative inverse of negative 3. I know what you're saying. I could just divide by negative 3 on both sides. I get it. I perfectly get it. And at this point, if you have mastered that, then you're more than welcome to do so. Me, I'm going to still use the multiplicative inverse of negative 3. Remember, this is negative 3 over 1. So that means that I'm going to have to use 1 over negative 3 or negative 1 over 3. It doesn't matter. The thing is that it has to be negative. See that? I know. You asking me, Becker, which one is negative, the 1 or the 3? It doesn't matter which one. In a negative fraction, one has to be positive and the other one has to be negative. Or one negative and the other one positive. So that's why when it's like that, you just put the negative in the middle, like where the division of the fraction is, okay, between the numerator and the denominator, and it's still negative. So anyways, let's go back. So negative times negative is positive, right? And anyways, what is the idea behind the reciprocal or the multiplicative inverse? To cancel out the numbers and leave you with the variable that you want. Okay, positive times negative is negative. 33 times 1 is 33 over 3. So 33 divided by 3 is 11. And boom, we got it. Here we go again. Alright, so do I have distributive property? Yes. Too much talking. Okay, so negative 2 times 3 is negative 6x. Negative 2 times negative 2 is positive 4, then plus 4x. equals 11. Do I have fractions? No. Do I have like terms? Maybe. Okay, so those are the like terms. Cool then. So negative 6x plus 4x is negative 2x, and then plus 4 equal 11. Now, do I have variables on both sides? No. Additive inverse? Yes. Look, the x is being increased by 4. So I'm going to use the additive inverse of positive 4, which is negative 4. And we get negative 2x. This cancels out. 11 minus 4 is, I have no idea, 7. And now I am going to use the multiplicative inverse of that, which is what? Negative 2 over 1, so it should be 1 over negative 2, right? Or negative, and then in between the fraction, like that. Alright, so the idea is that when you divide and multiply by the same number, they cancel out, so that's 1x, so x. And now, positive times negative, negative. 7 times 1, 7. Divided by 2 is negative 7 over 2. I know what you're thinking. Yeah, but that's negative 3.5. Yeah, but this is high school. Just leave it as a fraction. Okay, don't worry about it. All right, let's move on. All right, so as I progress, I'm going to start using, you have to justify the steps. I'm just going to solve the equation.
Number 4 is focusing on sleep. You see, a lot of us put sleep by the wayside, but we have to realize that sleep is what optimizes the hormones that I just mentioned before, which therefore...
I keep on writing like terms as LI, it's LT.
He's getting the right coach. You see, it's one thing to have a coach that looks the part, but it's another thing to have a coach that looks the part, but also backs everything with science, because you don't want to end up with a coach...
Okay, so I'm going to start.
...what he used to get in his own good shape. You have to have someone that can understand principles for everybody and truly understand science. So if you want to learn more, I created a free full-length video that gives you the...
Okay, somebody, this is too much talking. What's going on here? Man, what happened to my video that I had? It was nice, OD nice. Okay. So now what? I'm gonna go straight to no fractions, like terms. Okay. 14 plus 11. Variables on both sides? Nope. Additive inverse? Yes. The additive inverse is not the 21, guys. It's the 25. Negative 21x is being increased by 25. So I'm going to use the additive inverse of 25, which is negative 25.